Okay, so this is our model truss roof.
Standard timber frame truss roof assembly with above sheathing ventilation.
So talk us through the components here. What have we got? This part here is kind of standard.
Standard truss, standard timber frame wall. What we're not showing here is a insulated surface cavity.
Yep.
Which, if you want to go, say, 140 mil worth of fibrous insulation, it's cheaper if you can get away structurally with a 90 mil frame to go 90 plus a 45 mil surface cavity.
Yep.
And you'll have a superior assembly R value
Yep.
by being able to insulate the surface cavity past the majority of the frame. So the only place you'll have continuous timber will be your bottom plate, your top plate, and around your windows.
Yep.
You'll have very small intersections of your horizontal surface cavity. Obviously, when you do that, you need to consider structurally your interior lining will just be interior lining at that point, and you'll generally be bracing with your rigid air barrier, which can also be dealing with wind, can contribute to the acoustics of the assembly. If it's a non-combustible material like fibre cement or a, say, jib weatherline, can contribute to a fire-rated wall assembly as well.
Yep.
With rigid on the outside, you can use the Intello Plus. It's reinforced so it acts as a bib for blowing in insulation.
Tell me
so
about
you're killing a whole lot of birds with one stone with that.
Tell me about what's going on here, and there's actually, if I can go under here, you've got another vented cavity here. What's going on with this ventilation?
We've got a traditional truss roof assembly, which would typically be direct fix.
Yep.
So we are proponents of above sheathing ventilation for a number of reasons, which we can go through. But typically, if you popped your head up into your attic space of an existing truss roof, you'd probably see daylight all around.
Yep.
And it's pretty leaky, pretty porous to air movement, so it ventilates well itself. Most likely the roof underlay will be lapped but not taped.
Yep.
Which is a funny thing about building code. We require the underlay to be an air barrier. It's one of the requirements of table 23 in E2 AS1, but the acceptable solution details don't show it installed in an airtight manner.
Yep.
So we're proponents of continuous external weather tightness and wind tightness, which means we are taping all the joints.
Yeah.
In this case, we've got an adhesive underlay which sticks on, so it sticks itself on all the joints. We're not penetrating it with a whole lot of mechanical fixings. This example of the model here has our Mento 3000 roof underlay.
Yep.
A couple of things we're doing differently here. So let's first talk about the direct fix corrugate. With direct fix corrugate, you wouldn't have the counterbatten, you just have the purlins, and you have the underlay on the purlin. So as the pitch decreases, with the underlay on the purlin, you have more risk of ponding.
Yeah.
You have all the roof fixings are going down through the underlay, penetrating the underlay, so a lot more penetrations. Where they do, they go through the high point of the corrugate invariably, so the underlay isn't clamped. Quite often it gets wound up that screw, and it's able to move with fluctuations in external wind pressure. And where a bigger hole, it's also required to be absorbent, so it's holding moisture around your fixing penetration of the cladding, and the quite often slightly different metals of the fixing and the timber treatment as well, which isn't ideal. We're also, with direct fix, we've got the cold cladding surface directly in contact with the underlay, so it cools it, causes it to condensate below and drip down into your insulation.
Right.
But here with above sheathing ventilation, we have minimized the penetrations because your roof cladding is fixed into the purlin only.
Yep.
The only penetrations of the underlay aren't going right through the external envelope, they're going through the purlin only. And we can put a Nidec tape, which is a 50 mil wide version of our butyl rubber sill tape. It's double-sided. We would stick on the counterbattens with that, so when that purlin screw comes through, it's sealed against any capillary moisture ingress at those locations. So we've got a much better external weather tightness layer. It's no longer in contact with that cold surface, so any condensate that occurs here will drip down and drain out. It's not cooling this enough to condensate below and drip into your ceiling insulation.
Right. And that's separated underneath, and you've got a big gap between the roof material and your underlay. You've got this
So vertical air movement can occur and drainage can occur underneath the purlins because we've packed them up.
Yep.
and we can also get side to side air movement. So we're ventilating around the perimeter.
Yeah, so let's have a look at that. So you've got a vented, and this cavity here is separate from this cavity because you've got a baffle up in between.
So first of all, we're ventilating the roof cladding cavity here. So we're draining it. So if you've got any problem with your roof, you'll see water coming out here, so you can address that.
Yep.
Direct fix corrugate, both the underlay and the cladding terminate into the gutter, so you don't know what's doing the work.
Yep.
So that's a benefit there.
Yep. And that vent goes all the way up to, we've got a fairly complicated looking ridge going on here.
We do, so we'll
that's
come back to that in just a sec. With this, we're running this all around the perimeter, so we're trying to harness wind pressure from a high pressure side to a low pressure side, regardless of wind direction.
Yeah.
So that's important.
Yeah.
We're not just doing it at the bottom and at the top.
Yeah.
If you've got a low pitch roof and you don't have potentially a story height differential in your roof, you won't really get much stack effect for warm air rising through it.
Right.
So you're relying on wind.
Okay.
In the same way as when you put your washing out on the line.
Yeah.
So we've got an absorbent surface. We're absorbing any condensate from the cladding. We want air movement through that to dry it.
Yeah.
So and you need intake and exhaust. So you're right.
Yeah.
So we're exhausting the roof cladding cavity here at the ridge. On a mono pitch, we would have the same detail up on the top.
Okay.
We'd have the same detail up your barges. And you can complement your eaves ventilation here with potential gable ventilation intakes as well.
Right, so you can put something on the end here as a vent. Yep.
Yep. So this is cladding cavity here, and then here we've got the truss space here. So it's really important to ventilate this because the moisture drive follows the energy drive, which we're in a heating dominant climate, so it's generally warmer inside than it is outside. So the temperature differential is occurring across your insulation.
Yep.
So we've got vapor drive into the attic space, and then because we're all sealed up, continuous external weather tightness, we've got nowhere for that to go, and potentially not much of a temperature differential to drive it through the diffusion open underlay.
Right.
So we need to dry that out by changing the air.
So through, if I can see it, that gap there, which is behind that baffle to stop the insulation material from touching the underlay, that is vented down through to
the soffit.
The soffit.
So this will be your intake.
Yep.
Air would move up and through, and it can exhaust out through the ridge. So if you look under here, you can see we have baffled that with a secondary layer at the ridge.
Up through there, right? Okay. So air can go up through there.
Can go out through there. So the ridge vent is exhausting. So
this is kind of two vents really, because you're venting the roof cavity space plus the above sheathing vent all through the one.
Yeah, 100% through the same thing.
Now that's quite a complicated looking detail. Is that something that an architect would have to get their head around, and then a council would have to figure it out, and then also a builder and a roofer would have to?
So our details are all online, so it's very easy for them to get that. They can. We've got good resource, so we can work with them to explain any of this.
Yeah.
Help them implement that on their project. Where brands are praised for the above sheathing ventilation detail with our underlays.
Yep. Awesome.
So full compliance for that. So yeah, it's pretty easy to implement.
So, easy-ish. But if you're going to do a truss roof, that's how you need to do it, right?
Mm-hmm. And again, air tightness on the warm side really important. So we've got Intello here.
So it wraps all the way around.
Yeah.
Yeah.
Quite often that goes directly on the truss bottom cord, and then we'd have ceiling battens below that, services. Your ventilation system ducts would typically be within the thermal envelope, so underneath the air as well. So consider the sizes.
Awesome.
So the other really good benefit of this whole assembly is that if you reclad, you're not going to touch the underlay. You've got your external weather tightness and wind tightness. You don't need a fully wrapped scaffold. So when you would go to replace the direct fix corrugate, obviously you open the building to the elements, you have to put a second underlay layer on. So this will pay for itself in the long term.
And what's the life of the underlay? How long would you expect that to last?
So we actually test more than we publish, but we would publish 90 days UV resistance for the roof underlay, 180 days for the wall underlay.
Yep.
They are effectively the same thing, just different colours. But that's why we have, compared to a competitor's product.
But would that have a 50-year life in situ? Like,
Yeah, so the only thing that will degrade this will be UV exposure.
Right. So I can sit there.
But as you can see, if you reclad, you would have a second UV exposure. So we give adequate time for the build process, allowing you to put this on, counterbatten and purl in it, and then weather protect your building as soon as possible.
Yep.
You're not dealing with something like a product that might have 7 days UV exposure, which is a pretty common one that's used in the market. Then you have to put the cladding on straight away. Yeah, so that's why we have that.
Yeah.
So there's a few things going on.
Yeah.
So we're active in this niche. We just encourage specifiers to engage with us.
Yep.
And we can give that
Cool.
feedback as early as possible in the design process.
Awesome. Thank you.
Thanks, mate.